OSPF, okay, so we have the neighbor states. So when it is going to form the neighborship, right, OSPF, neighbor states. So actually, generally, see guys, so to form the neighborship, it is going to be passed from the 7 states. Actually, we have the 7 states in OSPF. 7 states. The first state is down. The second state is init, which means initialization. The third one is two-way. The fourth one is extract. And the fifth one is exchange. Sixth one is loading. And the seventh one is full. So these are all the 7 states. Okay, when the router between two routers, if you have two routers, router 1 and router 1 and router 2. So consider here we have like 172.16.1. And here we have 172.16.1.2, right? So we have two different routers. So when we configure OSPF here and here, routers OSPF, both the routers in OSPF, right? So the very first state is down. So both the routers are in a down state. Okay. Then router 1 is going to be initiate the message. That is your init message. So let me take that. The very first message, it is going to be init message, which means the initialization. Init message stands for initialization. In initialization message, okay, what it is going to send, right? So router 1 is sending, hey, my router ID. So it is going to be involve his own router ID, and it is going to send the init message, and it is not going to see no one in the OSPF domain. So when it is sending the init message, it is going to involve his router ID. See, whatever the router ID. So we discussed, right, in the router ID there are 3 criteria. The first priority is going to give the manually configured router ID, and the second priority is going to give the loopback address with the highest loopback address, and the third priority is going to give the highest physical IP address. If you take in our scenario, we have the only highest physical IP address only. So that is going to be involved here in the init message. It is going to send the init message. So to respond to that init message, router 2 is going to send the another message which is two-way. So in two-way message, what it will happen, right? Router 2 is going to involve his own router ID, and it is going to respond to that particular init message. So router 2's router ID here, it is going to share the router 2's router ID. So till here, the two-way is completed. The first one, the very first thing, it is in down state. Then router 1 is going to send the first message, which is a init message, and it is going to share his router ID. To respond to that, router 2 is going to share his router ID in the two-way state, so that both the routers are going to form the two states in the two state in this hello message. Okay. Now, what will happen, right? The extract state will happen. So extract state. So in the extract state, okay, here it is going to be decided which router is going to exchange the database description. Yeah. So in the first message, see, the router 1 is again going to send the extract message. So in extract message, what router 1 will tell, right? So I will start exchanging because I have the highest router ID. So router 1 is having his router ID, right? And router 2 is also shared the router ID to router 1, and router 2 will also share the router ID in this state, right? So both their own router IDs, and they are going to become the who is going to become the master and slave. So in this scenario, what will happen, right? In the extract state, so router 1 is going to tell to router 2, hey, I have the highest router ID, so I'm going to exchange the DBD, database description. The same thing, router 2 will also going to stay in the extract state. It is also going to send the extract message. Okay, hey, I'm having the highest router ID. So it is going to send and it is going to send. So both the routers, see router 1's router ID is what, like 172.16.1.1, and it got the router 2's router ID also. It is a 172.16.1.2. So router 2's router ID is 172.16.1.2, and router 1's router ID is 172.16.1.1. So in this scenario, so router 1 will check, right? Okay, my own router ID is 1.1 and the router 2's router ID is 1.2. Router 2 will also check, okay, mine is 1.2 and the other router, the peer router ID is 1.1. So who is the highest router ID is having? This is having the highest router ID. So it will become the master. So he is going to exchange, right? He is going to start the first message, the exchange. He is going to send the database description, DBD, database description in the exchange state. So now so they decided, right? They both are decided, whoever having the highest router ID, so that router is going to send the extra exchange message. See here. So he is going to send his backend network, and this router will also going to send his own backend networks. Now, so both the routers are going to be load the shared database description in both the routers. Then it is going to be in the full state. So it is going to be send the acknowledgement like, okay, thanks for the sharing. Thanks for the sharing your backend network. So in OSPF we have a 7 states. So the first state is down, init, two-way, extract, exchange, loading, and full. So in down state, both the routers are in down. We haven't enabled the OSPF. So once you enable the OSPF, once you enable the OSPF, guys, once you enable the OSPF, the router one is going to send the first message, which is an init message. In init message, what you will see, so it is going to send the hello message in the initialization with his own router ID. The same thing, router 2 is going to send his the two-way message. In two-way message, it is also responding to that hello message along with his router ID. Okay, so then both are going to form the neighborship. So once it form the neighborship, then we will have an extract message. In extract message, okay, it is going to be like calculate, right? It is going to be evaluated which router ID is high. That router is going to be sent the like the exchange DBD information, database description information. So whichever the router is having the highest router ID, that router is going to exchange the backend networks, the database description. Then both the routers are going to be uploaded there. Okay, information, whatever the information they got from his neighbors, then it is going to be installed into run the SPF algorithm, shortest path algorithm, and it is going to be calculated the cost. Based on the cost, it is going to be loaded that particular network into the routing table. So this is what happened in the backend network, guys. But in interview, every interview, they are going to ask you, so what is the what is the 7 states? What is the states of the OSPF? So be familiar, be ready with this answer. So this is how we need to be answered. Likewise, in OSPF, we have a packets, OSPF packet types. OSPF packet types. In OSPF, we have 5 packets. The very first packet is hello packet, and the second one is DBD, database description. DBD stands for database description. The third one is LSR. The fourth one is LSU, and the fifth one is LSAC. Hello message will contain the information of, just now we discussed, right, in the 7 states also. In hello message, it contains the information of router ID, the hello timer and the dead timer, right? And in DBD, database description, in DBD, it will contain the database description. So this is going to be work in the word like the database table, and DBD stands for database data database database description, database description. LSR stands for link state request LSU stands for link state update. LSAC stands for link state acknowledgement. Link state acknowledgement. So these are all the 5 packets in the OSPF packets. In interview, if they are going to ask you, right, so what is the 5 packets in the OSPF packets? Then you can tell that, okay, we have the 5 packets in the OSPF: hello packet, DVD, database description, right? Database description, link state request, and link state update, and link state acknowledgement. Likewise, guys, if you want to form the neighborship between the two routers in the OSPF, router 1 and router 2, so few of the criteria has to be matched, right? So actually the router 1 is going to send the hello message to router 2. Even the router 2 is going to send the hello message to router 1. So what exactly the hello message is going to be contained in the hello packet? So the hellos, we know that hellos are going to be sent to form the neighborship, right? In the hello packet, to become the neighbor, to become R1, neighbor as a R2 and R2 neighbor as a R1, to become the neighborship, few of the criteria has to be matched, right? Like area ID, the first thing, area ID has to be matched. Then network ID and the subnet mask. I told you, right? So the both the routers has to share the same link, and the both the router should have the same network and the subnet mask. So we can use here 172.16.1.1/30, here 1.2/30. So then only the both the routers are going to form the neighborship. If you are using here 172.16.1.1/30 network, and here in this particular interface if you are using 172.17 network, then this both routers are not going to form the neighborship, because to form the neighborship both the routers should have the same network ID, and mask, or you can call as a subnet mask. Along with that, the hello timer, hello and the dead timer, hello timer and the dead timer has to be matched. So the default hello timer is 10 seconds, and the hold on timer or the dead timer is the 40 seconds, right? Hello interval and the dead interval both has to be, the default has to be 10 seconds and 40 seconds, and here also 10 seconds and the 40 seconds. If you modify this timers, right, if you modify in any of the router, even though if you are sharing the same link, if you are using the same, network and subnet mask, then also it is not going to form the neighborship, because it is also has to be matched, like dead intervals hello and dead intervals has to be matched to form the neighborship. And one more thing, the fourth thing is it's an optional thing. It's a optional. Optional means if you configure authentication in this particular interface, like the authentication, and here also the same authentication has to be matched. Like optional, you can mention here authentication. If you configure the authentication, then it is also has to match the authentication. So once it forms the neighborship, it is going to be it is going to be like from the adjacencies. Okay, it is going to be from the adjacencies. So this is what has to be matched, guys. And when we are going to configure the EHRP between the routers, we should know about the syntax as well. We should know about the syntax. So what is the syntax to configure the OSPF? To configure the OSPF, the syntax is the very first thing. Every router, we know that we need to enable the routing process, IP routing. Then we need to configure like router OSPF and the process ID. Here we need to mention the process ID. Process ID should not be case sensitive, but area ID is the case sensitive. Okay. Then you need to mention like network ID and wildcard mask. Wildcard mask is nothing but it's an inverse of your subnet mask, so which we already discussed on this in detail, right? So you just go through with that video as well, you will get to know. So it's an inverse of actual your subnet mask. Then we have a command like area. So here you need to mention the area ID. If you have multiple networks, the same command you need to be repeat, guys. If you have multiple LAN information, like if this is the router one which is connected like this, right? So here you have a network. So for this, you need to repeat this command one time, and for this LAN network also, you need to repeat the same command another time. Right? So this is how you need to be configured. So you just need to be introduced your directly connected network. Note down this point also. Like in static routing, we need to configure the destination network, right? The destination network. So that we need not to configure here. In dynamic routing protocol, we just need to introduce our directly connected network information only. So it is going to be from the neighborship. It is going to form the neighborship. Clear? So this is one of the few of the things which we need to be memorized, guys. Okay. So at every time, so in interview, they are going to ask in the interview. And one more thing here in the OSPF, we have the areas concept, right? We have the areas concept. Let me discuss about that as well. So because as we are trying to cover all the things, right? So in OSPF, we have an area concept. So we discussed, right? It's a hierarchical design. So in area, so we have the backbone area, or you can call as a area zero, backbone area or area zero, and we have a regular area, regular area. So backbone area is nothing but, so whichever the routers are belongs to, like the area zero, that routers are going to be area, backbone area, and the regular area we have like we have in regular area we have a normal areas. So based on this, see, so area zero is your backbone area, and the remaining areas are called as a regular area, regular area. So here in the OSPF areas concept, to join the multiple areas, we have a OSPF routers types as well. We have a OSPF routers types. We have a different types of routers because we just now we discussed, right? We have areas. To join these areas, we have a different routers also, right? So we have a BR, backbone router. BR stands for backbone router, and we have a ABR, area border router. Area ABR stands for area border router, and we have a ASBR. ASBR is nothing but autonomous boundary router, and IR, internal router. Internal router. So these are all the routers we have. See, in OSPF we have the areas, backbone area and regular area. So whichever the backbone router is belongs to the area zero, that router is going to become as a backbone router. And to join to multiple areas, we have a ABR, area border router. And to join two different area, like two different routing protocols, we have a ASBR, autonomous system boundary router. So and whichever the regular areas we have, on that area we have the different like the routers, and those routers are going to call as a internal routers. Those routers are going to call as a internal routers. Right? Internal routers. So this is what about your like areas things, like in the routers types, in the different types in the OSPF. And even we have the LSS. This is also very important thing. Okay, what is LSS? In every interview they are going to ask you, okay, OSPF LSA types. OSPF LSA types. So in OSPF LSS types, the first LSA is a router LSA. In the second LSA, we have a network LSA. The third one is we have a summary LSA. The fourth one is ASBR LSA. and we have an external LSA. LSA5 is the and the sixth one is multicast OSPF LSA. The seventh one is we have like NSSA, OSPF not so stubby area LSA. The seventh one is NSSA, OSPF not so stubby area LSA. So LSA1 is generated by each router. Okay, LSA1 is generated by the each router in the area. Okay, it is not going to cross the area. LSA1 is only within the area only, and the LSA2 is your network LSA. So network LSA is going to be generated in the DR and BDR, DR and BDR kind of networks, like broadcast type of network generated by the DR. So which includes the link state ID, that will be the interface IP address of the DR. So LSA1 is going to generate the every router in the area, and LSA2, which is a network LSA, is going to generate it with the DR, and the LSA3 is what? The summary LSA. Summary LSA is created by the ABR, area border router. Flood, it is going to be flood into the other area. So we discussed, right? We have a different types of routers, like we have the internal router, we have a ABR, area border router, we have a ASBR, autonomous system boundary router, and we have a backbone router. So BR, backbone, like area border router, is responsible to join two different areas. It is going to be relay in between area 1 and area 0, and this guy is going to be populate the routes from area 1 to area 2 and area 2 to area 1. So he's going to be work as a man in the middle. Okay, and the area border router is going to be responsible to generate the summary LSA. It is going to be flood to the from one area to the other area. ASBR, autonomous system boundary router. Okay, so for the ASBR, autonomous system boundary router, also on behalf of ASBR, ABR is going to generate his router ID, and it is going to be flood to the different areas. And the external area, external LSS is nothing but external LSS are like also known as the autonomous external LSA. Okay, and these external LSS are generated by the ASBR, like from one different routing protocol to the other different routing protocol. So it is going to be redistribute the routes. So it is going to be generated by the ASBR router actually. So here we have a ASBR LSA, but on behalf of ASBR, it is going to be generated by ABR router, area border router. But LSA5 is the external LSA. External LSAs are generated by the ASBR router. And here, like multicast OSPF, so it is only be generated on the multicast level, the multicast routing. So we are not going to, it is absoluted, it is not going to be used. So we have the last LSA 7, which is not so stubby area LSA. In not so stubby area LSA, okay, you can see not so stubby area LSA, which does not allow actually LSA5 guys. So if you are going to configure any of the router, like so this router has a stub area or not so stubby area NSSA, so that router is not going to be. So in this particular area, so the LSA5 is not going to be flood. Okay, to overcome this issue, we are going to generate as LSA7 and instead of LSA5, and it is going to be involved. So whichever the router you are going to configure as a stub router, right? The stub router, that router is not going to be accept the LSA5. Okay, it is only accept LSA7. That router will have only one single point 2 and 4 of the network. So we discuss about the normal area, backbone area, stub area, and the totally stub area as well. Okay, so this is a very like. And one more thing, guys, in the OSPF we have this one, right? In the OSPF we have a DR and BDR election, like the DR and BDR election as well. So DR stands for designated router and BDR stands for backup designated router. So DR and BDR election will happen in the broadcast kind of network. Like broadcast, see, if you have a switch here like this, and for this switch you are like you have a multiple routers connected. So among these three routers, router 1, router 2, router 3, so the DR BDR election is going to happen because it's a multicast kind of network, broadcast multi-access network. So here the DR BDR election is going to happen. One of the router is going to become the DR, the other router will become the BDR, and this is DR other, BDR other. So this is going to become the other router. So all the routers are going to form the neighborship in DR, and DR is going to generate the DBD, database description. So actually, generally when we are going to discuss, right, so the multicast status 224.0.0.5 and 224.0.0.6. So for the multicast 225.0.0.5 is going to use, but in the DR and BDR election, so DR is going to send the DBD, right, database description. At that time, it is going to use 224.0.0.6. 224.0.0.6, and this DR and BDR elections are going to happen based on the priority. By default, every router will have a priority is 1, and we can reduce that. Whichever the router you are going to configure on this interface, the priority as a 0, that router is not going to be participate in the election. So whichever the router, by default every router will have a priority as a 1. So if you want to make this router as a DR, so you need to be increase the priority. You need to increase the priority. If you increase the priority, right, so this router is going to elect as a DR, and the second highest router is going to become as a BDR. So this is what the quick overview of the OSPF, guys. So we done about like quick overview. We covered all the points in the OSPF, right? So the functionalities are the specific, like the functionalities of the OSPF. The functionalities of the OSPFs are like what is OSPF, Open Shared Spark First, and which algorithm it is going to be used, and it's a link state routing protocol, and the AD value of this one. The hello, what is the hello timer and the dead timers, like multi-hop, like unlimited hop, like what is the metric of this OSPF protocol. Then we discuss about what is router ID, right? So router ID is very important when it is going to form the neighborship. When the routers are going to form the neighborship, it is going to see, so from which router I receive this particular information. To calculate the router ID, we have the three criteria. To manually configure router ID is going to give the first priority, and the second priority is going to give the highest loopback address, and the third priority is going to give the highest physical IP address. So we can configure the loop like this, like interface loopback number, and the IP address and the subnet mask, right? And then we discuss about like the OSPF tables. So how many tables OSPF is going to be maintained? OSPF is going to maintain the three tables: neighbor table, or the topology or database table, and the routing table. So neighbor table will contain the information of directly connected neighbor information, and the database table will contain the information of whole topology, right? The complete topology, which is going to see the overview like that from the top view, and the routing table. So the routing table will contain the best part towards the destination. So once it calculated the SPF, once it run the SPF algorithm, and which is calculated whichever the best route is there, that route is going to be stored into the routing table. So to check the neighbor table, the command is show IP OSPF neighbor, and to check the database table, the command is show IP OSPF database, and to check the routing table, show IP route. And if you want to filter specifically to the OSPF routes only, then the command is show IP route but include OSPF. This also we covered, and then we discuss about the what is the advantages of the OSPF, as it is a fast convergence. Okay, so whenever there is a change in the network, it is going to update incremental and triggered update, right? And even there is a LSA link state advertisement of every 30 minutes, every 30 minutes. It's that LSA is also called as a refresh LSA, like refresh LSA. And in advantages, we covered about the fast convergence and the scalability, because we are going to use the hierarchical design, like we are going to divide the networks, right? Different areas. We are going to divide the different areas. We discuss about the load balancing as well. And you need to memorize this point. The OSPF is going to be do the load balancing only in the equal cost load balancing. And the security in the OSPF, we have the authentication mechanism. We can use the plain text authentication or the MD5 authentication to authenticate the neighbor, whether the neighbor is the genuine neighbor or not. In OSPF, we have the neighbor states. We have total 7 states: down, init, two-way, extract, exchange, loading, and DBD. So we discuss about this in detail. So just go through the video. We will get to know and prepare the notebook as well. And OSPF types, like the packet types. In OSPF, we have the 5 packet types: hello packet, DBD, database description, LSR, link state request, and LSU, link state update, and link state acknowledgement, right? And we discuss about this to form the neighborship. What are the conditions has to be matched to form the neighborship between the routers? Like the first thing is both the routers has to share the common link, and both the routers in the same area ID, and the network and subnet mask. Hello and get timer has to be the same. If you change in one router, the other another router, the peer router has also be need to be changed, or else it is not going to form the neighborship. And the authentication thing, it's optional. If you configure the authentication, the other router should also be come up with the same authentication with the hello packet, or else the router one is going to be discard that packet. And to configure the OSPF, the syntax is router OSPF and the process ID. Process ID is not case sensitive. In one router you can use 10, in the other router you can use 20. That's not going to be happen, like that's not going to be make any issue. But this one has to be matched, like network space, network ID, and the wildcard mask. We discuss about what is wildcard mask in the previous videos as well. Here also we discuss like the wildcard mask is nothing but it's inverse of your actual subnet mask. There is a formula to calculate this. So wildcard mask equals to actual subnet mask divided by your subnet mask, the global subnet mask. Actually, the global subnet mask is nothing but 255.255.255.255. All the portions are 255 divided by the actual subnet mask, whatever the class you are going to be use that subnet mask. So once you evaluated this, right, so whatever the value you will get, that is will become your wildcard mask. And area ID. So to form the neighborship, both the routers, both the connected interfaces should be in the same network. So how many networks do you have? That many times you need to be repeat this particular command, like network space, network ID, and the wildcard mask. Then we discuss about the OSPF areas concept. So in OSPF we have a backbone area and the regular area. So the router, whichever the router is belongs to the area regular area, all the router has to be connect with the backbone area to form the neighborship, right? And in the OSPF router types, we have a backbone router, ABR, area border router, which is going to be join the multiple areas, the 2 different areas. Okay, is the responsible to join the 2 different areas. And ASBR, autonomous system boundary router, it is responsible to join the communication between the 2 different routing protocols. And the IR router stands for internal router, which is belongs to the regular area. And in OSPF we have the LSS, right? We have the LSS. In LSS, the very first LSS, LSA1 is the router LSA, network LSA, summary LSA, ASBR, autonomous system boundary route, external LSA, multicast, OSPF LSA, not so stubby area LSA. Even we discuss about the DR and BDR elections. So whenever you have a non-broadcast multi-access or the multi-access kind of networks, there you will have a DR and BDR elections. So every router will have the default priority is 1. So whichever the router you wants to make as a DR, so that router you need to be increase the priority. If you increase the priority of this particular router, this is going to become your DR. And the other router, the second highest priority is going to become your BDR, and the other routers are going to become your DR others. So in the absence of DR, if the DR is going to be down, the BDR, whichever the BDR you have, right, that is going to become as a DR. That is going to become as a DR. And these elections are not preemptive. These elections are not preemptive. Yeah. So this is what the quick overview of the OSPF.